My name is Adejumobi Joshua. I'm currently a graduate student of Carnegie Mellon University, Africa in Rwanda. So it's nice to be teaching you this virtually. So I hope you learn from this and then you are able to extend this work to other languages. Okay, so what we'll be talking about today, we'll be seeing how to evaluate embedding models on the Yoruba subset of a benchmark called MiraCL. So MiraCL is an information retrieval benchmark, right? That contains, for the Yoruba subset, it contains Wikipedia passages and about 119 queries for 119 queries, just that. So the goal of this notebook, just like I've said, or the goal of this session, right, is to see how to evaluate embedding models on a benchmark. And our case study is Yoruba. So I'm sure not every one of us would have heard of what an embedding model is or what it does, but I'm sure most of us have heard of what we've heard of ChatGPT. We know what Claude is. We know most generative models, right, in today's world. So we'll be seeing what is the difference between embedding model, this embedding model that I'm talking about, and also how it differs from a generative model. And then when you have an embedding model, how can you evaluate it, right? So we'll be seeing how different metrics like NDCG at 10 and also recall at 100, we're seeing how those works. So the question that I want to answer is, how well do current multilingual embedding models, how well do they work, right, when they want to retrieve? I told us that MiraCL depth set of subset of Yoruba contains Wikipedia passages, so we'll be seeing how well they retrieve that. And the embedding models that we'll be focusing on are BGEM3. We also have the fine-tuned version, right, of BGEM3. We'll be seeing how well that also works. We also have Multilingual E5. And then the last one is LABSE. So LABSE is a language agnostic birth sentence embedding model, which was developed by Google Research. So we'll be seeing how all those work in today's demo and how if they work as well, right, for Yoruba. So what is an embedding model, right? How different is it from a generative model? So embedding model, right, you can also have access to it through an API, right, if it's like closed source, but if it's open source, right, you can always download it on your local using your GPU, right, to have access to it, right? So we're trying to tell you that fine, just the way you can have access to your GPT 4.0 and also an API, you can also have access to an embedding model through an API. And just like you can have access to Llama 3.18 by downloading it on your PC, right, from Hugging Face Up, right, you can also do that here, right? And that is what we'll be doing, right? We'll be connecting to Hugging Face Up and then running those models, embedding models, locally, right, on our PC. Sorry, did I say PC? On Colab, right? We're running it locally on Colab. So what's the difference, right? So embedding model, fine. We know both embedding model and generative model, they give you give the input, right, as text, but then the output differs, right? So an embedding model will give you an output of a vector of numbers, while a generative model will just keep on predicting, the next text, right? And then the main job of an embedding model is to measure the semantic similarity, right, between two words, right, that has been given, while a generative model, can generate reason, answer questions and all. And then mostly for retrieval use, you want to use an embedding model because it's expensive, right, to use a generative model for that. So an embedding just easily converts text, right, to a point in a high dimensional space. So convert text to vectors, right? And that vectors with the same vectors that are similar, right? They are going to land in similar space, right? In that high dimensional space. Therefore, if you want to now calculate the similarity, right, you can just calculate, right? You can just calculate the similarities between, when you ask the question and then the vectors, right, that has been embedded as the document. So when you calculate, like, for example, the cosine similarity, you're just looking at the similarity to when you ask a question, which of this, the question that you ask, how similar is it to the document that has been embedded? So you'll be able to see which document best answers your question. Fine. And how do we use this embedding model for a method like retrieval augmented generation? So all you have to just do is, so we'll not be covering that in today's scope, right? What we are going to cover, just like I said before at the beginning of this notebook, is to see how to evaluate, right, this embedding model on a benchmark, such that you can take it further, find a benchmark for a new language, and also try to evaluate some embedding models, right, on your language of choice. So now we are just taking a quick detour to see how they work in retrieval augmented generation. So all you just have to do when you want to use it for RAG, right, is to get your document, right, that you want these models to retrieve from, then you embed them, right? So when you embed them, you get vectors. We already showed you earlier that the output of an embedding model, right, is a vector. And then, so when you're done embedding them, right, the next thing is going to be stored in a vector database. We have different vector databases, like, for example, we have ChromaDB. Then you also embed the question, right, with this same embedding model, and then it gives you a query vector. So this is the similarity search I was trying to explain the other time. So now we have the document vectors and we also have the query vector. So we now do a similarity search based on the question, right? We have a question vector, right? How similar it is how similar is it to the document stored in the vector database. So you are going to get some set of relevant passages, right? Relevant documents to the question, right? So it is this question, it is this relevant passage that you now pass to the generative model, right? This question, this passage is what you pass to the generative model. Then you now get your final answer. Some of us might not know why we use RAG, and I'm sure most of us, right, we would know, what RAG is used for. Fine, we just use retrieval augmented generation, right? We use it to augment a language model's knowledge, such that it would be able to have access to information that it has not seen, right, during its training phase. So in this kind of situation, maybe you have some specialized Yoruba knowledge, right, that you doubt that, a language model might have seen, right, during its training phase. You can use retrieval augmented generation for it, such that when a user asks a question, it can just retrieve the most relevant, right, document, looking at this simple scenario. So you can just retrieve the embedding model will retrieve the most relevant document and then pass it to the model. The model can now use that, right, to update its answer, giving a more reliable answer. All right. So now we are going to be seeing how, so I'm sure we all understand, though this is virtual, right? I'm sure you can always send your question over to me if you have any question. So we know about the goal of today's technical session, and we know what an embedding model does. We know what an embedding is, and we know how it complements a generative model, and we know what RAG does, right? And how RAG can be helpful. All right, so moving on, we are going to just see this toy example of what how cosine similarity works. So for cosine similarity, we usually have a range between 1 minus 1 and 1. So we have a range between minus 1 and 1. So it just shows how similar, right, two vectors are to each other. So if we have a cosine similarity of 1, that means those two vectors are very similar and they are moving in the same direction. If we have a number, sorry, excuse me. So if we have a cosine similarity close to 1, right, it means they are still very like similar, right? But if we have a cosine similarity of 0, that means that there is really no similarity, right? But if you have a cosine similarity close to -1 or -1, if it is -1, then they are in opposite direction. So that is how cosine similarity works. So yeah, we are just giving some toy vectors and we want to see the cosine similarity between them. All right, so I've started running this. Yeah, so for this to run fast on Colab, you'd want to like connect to a T4 GPU such that just for it to run fast. So you can see the cosine similarity for passage about Shango. You can see that it is 1, right? So it's just like a toy to explain, yeah, it's just a toy code to explain how cosine similarity works, right? So I'm sure you already understand how cosine similarity works and the range, right, that we can have for cosine similarity. So I'll be moving on to the actual benchmark that we would be using today. Yeah, so I'll be moving on to the actual benchmark that we'll be using today, and that is our MiraCL data set. All right. Okay, so let me refresh my Colab notebook. Yes, so we have some packages to install. So after installing these packages, we import every library that we need. I'm currently connected to a GPU, as you can see. So you should also connect to a GPU on your end. Here we are defining our metrics that we want to use. You can see NDCG at K and then recall at K. So we will be explaining these different metrics as we move on in this notebook. And the reason for using 10 and 100, you'd also be seeing that as we move on in this notebook. So here we're just trying to introduce the MiraCL benchmark, which I've explained before. I said the MiraCL benchmark is a multilingual information retrieval benchmark, and I told us about how the corpus is of Wikipedia pages, and then we also have 119 queries, right, for the Yoruba subset, right? And then we have the queries, we also have the corpus, right, which is the passages that we want to retrieve from, and then we have relevance judgment, right, which is telling us which passage, right, are known to be relevant for each query, right? So it is this relevance judgment that we'll be able to use, right, with our metrics, right, to score the metrics that we'll be using today. So here we just have a function to download MiraCL from Hugging Face Orb. So, and that is what we are trying to do. So here we are just defining our functions to download NeuralCL from Hugging Face Up. And then here we are trying to actually download that data. And right now we are trying to see an example, right, of that query. So here you can see the query, the first one, which we are using as the example. We have ọdún wo ni wọ́n ṣe ìdíje Olympic àkọ́kọ́. Then you can see the relevant passage, right, which we are picking from QREL, right, the relevant passage data, part of the data, right? And then you can see that that query is actually relevant to that passage. So we'll move on to the 4 embedding models that we are going to be using today. So we have BGEM3. So we are going to be using the base BGEM3, right? And then we also have a fine-tuned BGEM3 on Nigerian languages. So this model has been fine-tuned on, I think, Yoruba, Igbo, and Hausa. So that makes it 2 versions of BGEM3 that we are going to be comparing, and then see how well they work on the NeuralCL benchmark, right? Then we are also going to be seeing the multilingual E5 embedding model, and then LABSC, the model that was created by Google. So here we're just trying to define the different specification of the model, right? You can see we defined for BGEM3 and also for the Nigerian fine-tuned BGEM3 on Nigerian languages, and we also have multilingual E5 and then LABSE. All right. So moving on, we said we'll be using cosine similarity majorly to see how close the query vectors are to the embedded, right, document, right? So you can see here we are trying to normalize each vector so that the dot product, right, can be cosine similarity. And here we are trying to define the different ways that we'll be encoding the queries and also the corpus, right? And then if you move down, we are also still doing the same for BGEM3. So this first one is for E5 and LABSE. Then the next one, we are also seeing how to encode for the queries for BGEM3, right? So I'm going to run this. Yes. So now that we have our helpers, right? Now that our helpers are all ready, then the next thing we have to do is understand our metrics, right? So we're concentrating on 2 metrics today. That is NDCG at 10. NDCG means normalized discounted cumulative gain. And then recall, right? We all know what recall is, right? So we'll also be seeing how recall works here, right? We'll be seeing that. So NDCG, right, what it helps to do is that it helps to see if the relevant results are ranked near the top. So are the relevant results, right, really ranked near the top? So when we retrieve some passages, right, it's going to like rank them. Some passages will be some passages will be retrieved first, right, as the most relevant, then another, then another, then another. So NDCG is helping to see, oh, how is the relevant passage, right, part of the top ranks, right? So that is what NDCG helps to do. So if the relevant passage, right, is part of the top ranks, then you are going to have like an NDCG value of 1. But if the relevant passage are not like topping, right, the ranks, then the value of NDCG, right, is going to be low, right? Then we'll also have so best question answered by NDCG is just showing how good is the ordering, right, from the search results. So we also have, and we are doing at 10, right? We are doing at 10 specifically because we are trying to follow the metric that was used in the Miracil benchmark itself, so that when we are done with this on your own, you can just search for I think BGM3 paper, right? They evaluated their model on Miracil, so you can see, compare the results, right, that we get in our notebook with what the paper got for BGM3. Right, so that is why we are using at 10 specifically. You can decide to use at 20. At the at just means that you are looking at only the first 10 passages. At 10 means you are looking at only the first 10 passages. So amongst the first 10 passages that was retrieved, right, as the most relevant, right, are the most relevant ranked, right, top among those first 10 retrieved passages. And then we also have the next one, which is recall at 100. So recall is saying that, did we retrieve the relevant material at all? So you can see the difference between NDCG and then recall at 100. So when you want to use an embedding model, based on the metric that you use, you are going to get, sorry, excuse me. So when you are using an embedding model, right, so based on the metric that you are using, the metric that is most important to you, right, you are going to get different values because they are all measuring something similar but different, right? So recall at 100 is saying, oh, did we retrieve the relevant material at all? So recall is not even looking at the ranking. Oh, NDCG is looking at, oh, the relevant passage, are they coming in the top ranks, right? But recall at 100 is saying, oh, did we even retrieve the relevant material at all? So among the top 100 results, right, that was retrieved, right, recall at 100 is saying how many relevant passages were even retrieved, right? So the example we have here, we have 5 relevant passages, right? And then the model just retrieves 4 of them, that is the embedding model. Then recall is going to just do 4 divided by 5, right? So anything at is just saying among if you have at 20, recall at 20, that means it's looking at among the top 20. So if you have at 20, saying if you among the top 20 results, right, what is the fraction of relevant passages that is there? But we are using at 100 now, right, which is saying among the top 100 results, right, what is the amount of relevant passages that we have there? So best question answered by recall is saying, if I pass the top candidates to another system, right, how much relevant information the retriever preserve? So here we are now writing our functions for NDCG and then also for recall, right? So we are writing that. And then now we are now trying to see a worked example, right? So we are trying to see what we'll have for NDCG and then also recall, right? So I know this is virtual, but I would want the organizers to like pause this and then ask the students, right, what they think the result for this is going to be based on the previous explanation about NDCG and then also recall, right? So what do you think the value of NDCG is going to be if we have some documents ranked this way? So this is a small worked example. So if we have some documents ranked this way, right, and then these are the exact relevant ones, right? So what do you think NDCG is going to be? Do you think NDCG is going to be close to 1 or it is going to be less than 1, right? And the second question is, what do you think recall, right, is going to be? The recall is very easy to calculate. So what do you think recall is going to be, right? So I'm sure they are going to give good responses, right, to that question, and I'm clapping for you because I know you are going to get it. So let's now run this to see what NDCG is going to be and what recall is going to be. Yeah, so recall is going to be 1 because, of course, it doesn't care about the order. It just cares that, oh, the retrieved document, right, should be among, sorry, the relevant document should be among the retrieved document. It doesn't care about their rank. So as long as the relevant documents are part of the retrieved document, so you can see that we have a recall score of 1, right? And then for NDCG, right, it cares about the rank, right? So the relevant documents are not ranked first. So you can see D2 coming second and then D5 coming last. So you can see that we are having an NDCG score less than 1. All right, thumbs up to you for getting that correctly. So now we now want to see how we are writing our function to embed, right? Sorry, we've already embedded our document. So we want to write the function to see how to retrieve our top K examples, right? Both for the NDCG and also recall, right? And also to calculate our metrics for each query. So now that we've done that, the next thing we are going to do, right, is to see this cell, right, which is going to get all our query text and also the document text. And for each model, right, is going to call the functions that we have defined above. So I'm sure you remember when we were defining these functions here. So let me scroll up. Yes, so these functions here for each of the different models, right? So it's going to use that now here. Yes, and then also calculate our metrics to see how well, right, these different multilingual models, right, are able to retrieve from our Wikipedia's 49,043 passages. That's if I'm correct. So let me confirm that. Yes, 49,043 Wikipedia passages. All right, so moving on, this is currently running. This is going to take a while to run. So let's just do a brief recap of what you've been able to learn while this is currently running, right? Right, so here we already understand what an embedding model does, right? What an embedding is, right? And we understand the different metrics that we can use to evaluate them, which is NDCG at 10 and also recall, right? And then we've seen different embedding models like BGEM3 and also the Vine-Soon version, and we've seen E5 large and LABSE. So now we now want to see how well, right, the current cell running is checking to see how well these different models, right, work, right, for retrieving Yoruba Wikipedia passages. We've also seen the difference between an embedding model and a generative model. We've also seen an instance, right, an example where they can be used for retrieval augmented generation. And everybody here, right, we understand what retrieval augmented generation is and why we use them, right, with language models. And then we understand the flow of how it works, right? Once you want to build that. All right, so and then we've also seen how to fetch our MiraCL data sets. We saw an example of how a query looks like, right, for MiraCL and how the relevant passage, right, looks like. And then the next thing we did was to load our model specifications. So after loading the model specifications, we move on to see how to encode, right, the different queries and also our corpus for the different embedding models, right? So moving on, right, we also explained what NDCG means, and recall at 100 and then NDCG at 10. And we all know that anything after the at is just looking at the number of retrieved passages. All right, so I would have, at this point, if it was a physical session, I would have said, oh, if you have any question, you can ask now, but then this is virtual, right? But you can always send questions that you have to me, and then I'll be happy to respond. So right now we are waiting for the cell, right, that is currently running the retrieval, right, for the different embedding models, right. We are currently waiting for it, right, to get completed. So once it's complete, right, we'll be able to see, right, at using a metric like NDCG at 10, right, which embedding model retrieves, right, the most relevant document, right, and which doesn't. So we'll be able to see that. And then we'll also be able to plot, right, the different values, right, that they got for this metric, looking at NDCG. And then we would also see here, right, we are going to see what the model actually retrieved, right, the passages. We'll be comparing between the base BGM3 and the Nigerian fine-tuned, you know, so it's fine-tuned on Nigerian languages, not just Yoruba. So we have it was fine-tuned on Nigerian languages. And then we're able to see what the models, right, actually retrieved, so that when next you want to do a retrieval task, you'll be able to say, oh, I think I can first evaluate, right, which retriever works best, which embedding model works best, right, for this language, right? So when you're able to get that, then you can say, okay, I think for example, if you want to build a RAG system, you can say, oh, I think the best retriever to use, right, for this language is this. Then you can get to work. Or let's say, for instance, right, you evaluate and then you see that all embedding models, right, multilingual embedding models, they are not working, right? They are not working for this particular language. They are not retrieving what they are supposed to retrieve, right, for this particular language. They have low scores, right? Maybe low NDCG score, or based on the metric you are using, right? You can now say, if you have the time, right, for a project, right, you can make that a research, right, to say, oh, you now want to be the one to take on that task, right, to make a better embedding model, right, for that language. So one thing you can also do, right, if you are in that kind of situation, is to fine-tune the embedding model. So in that kind of instance, right, you can get data sets, right? You can look for data sets, and I've forgotten the word right now, but I can always get back to you. But the kind of data set that you'd have to look for, you would have to have the positive pair and then also get the negative pair. We call the kind of fine-tuning that you can do, right, for an embedding model. An example of fine-tuning that you can do, we call it contrastive fine-tuning, right, where you show the model the positive and then the negative, right? So the model learns that, oh, this, you have a query and then you have the positive that is like closer to the query, and then you also have the negative, right, that is far away from it, so that the model can learn that, okay, this connects, right, this have the same meaning, and then the negative one, they are different, right, they are totally different. So we've also done something like this. So while this is still running, right, so let me reshare my screen and show you a similar paper that does that, so that you can get inspired, right, such that if you want to use a if you want to use an embedding model for a language, right, and then you can see that you first evaluate, right, that model, and then you are seeing that, oh, it's not performing as well as we would want it to, right? If you have more time at hand at that instance, right, you can just fine tune, right, the model, right, to become better at that particular language, and you can draw insights from this paper. So let me share my screen. So I will share my screen for the paper. Yes, so I'm sure you can now see my screen now, so you can be inspired to do something like this related to this. So you can see that, yes, because we did use contrastive fine tuning, right, to improve the embedding model for Nigerian languages, right? So you can take insights, right, from this kind of paper, right, if you are in that kind of scenario. And then you can see that for each training query, right, this is paired with not only its relevant document, but also with irrelevant ones, right, so that the model can see, oh, this is similar, and then this is dissimilar, right, when you are doing your fine tuning. All right, so let me stop sharing and then move on with our evaluation. So I will share my screen. Yes, so our results are here. So you can see the base BGEM3 doing very well at NDCG at 10. And then you can see multilingual E5 also doing well. Your Nigerian fine-tuned BGEM3 also doing well. But NABSE is really lagging, right? While for recall, right, you can see BGEM3 doing wonderfully well. All right. And then for multilingual E5, doing well also BGEM3 also doing well. The fine-tuned version coming second. I think they've made some changes to this base BGEM3, maybe improved it at some point. And then we can see the recall. So recall doesn't really look at ranking, right? Just sees that, oh, are all the retrieved documents here, then it's good to go. But NDCG really looks at how the documents are ranked, and I think that is the most important, right, to us. So you can see based on NDCG, right, the different values, right, for the metrics that we were able to get. So now we've seen the metrics. Let's now see the passages that were actually retrieved, comparing BGEM3 to the fine-tuned version. So for this, you can see the query ọdún wo ni wọ́n ṣe ìdíje Olympic àkọ́kọ́. So you can see the relevant passage. For BGEM3, the relevant passage was ranked first, right? I know that will give a higher NDCG score. And then while for the fine-tuned version, the relevant passage was ranked second, which will lead to a lower, right, NDCG score. So far so good. We've been able to see how the different we just looked at 4 types of multilingual embedding model. Like looked at the base BGEM3, which I'm sure they've improved, right? And then we also have multilingual E5, and then the fine-tuned version of BGEM3, and then Google's LABSE, which seems to be behind, right, in this evaluation. Right, so we can see that these embedding models, right, they perform very well, right? They are performing, right? They've on Yoruba, right? They are actually doing well, right? Having scores greater than 70% for the different metrics that we evaluated, right? But you can move this further by looking for a benchmark. If you cannot find a benchmark, you can create one, right? Look at how Miracl was created, and then try to create your own, maybe for a language of your interest, like Igbo, or if you are Igbo, right, you can create that, and then see how well, right, these models are actually doing, right, on our language. So apart from these open source ones that we considered, right, apart from BGEM3, ML, multilingual E5, right, that we considered, we also have other embedding models, one from OpenAI, right, like text embedding, I think 03. So you can also compare, right? You can move this notebook forward and then compare other embedding models that we did not consider, that I did not add, right? Compare them and then see how they would work for this case study Yoruba, or you can do more and move further, do it in your own language. So I hope we've been able to like learn something new, right, in today's workshop. You've been able to see how embeddings work, and you know what an embedding model is, you know the different if they ask you to name like 2 or more embedding models, I'm sure you can do that. You know what generative models are, you know what RAG is, and you know that retrieval and generation are actually complementary, right? So they work hand in hand, right? And you know the different metrics, right, that you can use to evaluate an embedding model, right? You know about NDCG, you know about recall, right? We also have MRR, which you can also read about or research about, right? And you got to know about a new benchmark, Miracl. So I'm sure you learned from today's session, and I hope to see you take this notebook further either by adding more embedding models, right, to what we have in this notebook, or replicating it for a new language of your choice. So thank you very much for listening to this session. If you have questions, you can always reach out to me. Thank you so much. I hope you enjoy the rest of your day. Bye.